Okay, so this is a lesson which will help you to do the light calculations section on Education Perfect. I've sort of gone through the lesson. It's too long to go through the entire thing with you, but I've identified the main aims of the lesson, and I'm going through a couple of examples of question types to match those aims. So the first thing we're going to talk about is the aims. One of the aims is to convert seconds to years and vice versa, and you're going to do that using a particular sort of combination of multiplications, and that is, in 1 year we want to know how many seconds there are. So there is 60 seconds in a minute times by 60 minutes in an hour times by 24 hours in the day times by 365 days in the year. Now, if you multiply this by a number of years times by years, you will end up with the number of seconds. If you do the opposite and you divide the number of seconds by this value, it will give you the total number of years. The next thing that we're going to do is calculate distances times or velocities using the velocity divided by equals the distance divided by the time formula. A very simple formula for motion. After that, we're going to apply the same formula, but when you have velocities, times and distances that relate to light years and the speed of light. So for question 1 is relating to this one here, converting seconds to years and vice versa. So the question is here, and the answering in Education Perfect is here, and we're just going to work through that. So the question 1 says, calculate how many years there are in 4.74 times 10 to the 9 seconds. So we're going to put in the information that we have. We know that this is the formula that's going to allow us to convert from years to seconds. We want to find the number of years, and we have the number of seconds. So the number of years is going to be much, much smaller than the number of seconds, which means we're dividing by this factor. So it's 4.74 times 10 to the 9 seconds divided by how many seconds there are in a year, and that will give you the number of years. And if you do this, it's 150 years. Here's another example of the exact same thing. However, instead of finding the number of years, you're trying to find the number of seconds. So we want to multiply the number of years by how many seconds there are in a year. This factor here gives us how many seconds there are in a year, and that's going to be multiplied by the number of years. So it's 848 times the 60 seconds in a minute, the 60 minutes in an hour, the 24 hours in a day, and the 365 days in a year, which gives us this value of 2.67 times 10 to the 10 seconds. Okay, that covers the first aim. The second aim is calculating the distances, times, or velocities using this formula. So here are some examples of how to do that. The question says, our walking speed on average is about 1.11 meters per second. Calculate how many years it would take someone to walk 3.99 times 10 to the 8 meters, which is the distance to the moon. So we're going to use the formula, velocity equals distance over time. They've shown it differently here. Okay, we can arrange that formula to find out what we want. In this case, we want to know how many years it's going to take. So we're going to rearrange it so that time is the factor we're finding. We know the distance, we know the velocity. So we have 3.99 times 10 to the 8 meters divided by meters per second, and that will give us the time in seconds. Now this is the only tricky bit here. We want to know how many years it would take for someone to walk. So we have to convert the seconds into years, and we do that just like we were doing in the previous questions. we have 3.59 times 10 to the 8 seconds. We're going to divide that by the number of seconds in a year, this value here, to give us our value for years, 11 years. Moving on. This question says there's a UFO and it's travelling from Alpha Centauri, which is another star fairly close to Earth, at 1.5 times 10 to the 8 meters per second. They want you to calculate how far away Alpha Centauri is if it takes the UFO 8.78 years to reach us. So we want to find a distance this time. So we're going to first of all convert our years into seconds so we can make this work. Using this formula here, we have 8.78 years. We're going to multiply it by the number of seconds in a year to give you the number of seconds, and then use this formula rearranged so that we're solving for the distance. We want to find the distance, and we're going to find that by multiplying the velocity by the time. Then we simply substitute in the unknown values. So we have this number here, which is 1.5 times 10 to the 8, times by the 2.77 times 10 to the 8 seconds, which gives you a distance of 4.15 times 10 to the 16 meters. So part of why these questions are confusing is these big numbers, and we should spend some time talking about what this means. This means 4 with 16 places after the 4. So it's a really big number. 2 of those places are a 1 and a 5, and the rest of those places are a 0. So you can see that that is a lot of meters. Question 3 type. So we've answered the first 2 aims. We've calculated distances using this equation. We've calculated the number of seconds and years and vice versa. And now we're going to go the next step, which is looking at light years and light speed in the same formula. So it's important information first. To convert between distances in meters and light years, the easiest method is to calculate the time it would take light to travel that distance. So we divide the distance in meters by the light speed in meters per second, giving us the time in seconds, and then converting the seconds to years. The time in years is equal to the distance in light years. So here's an example of that. That sounds really confusing. If we do an example, it will make sense. So if the distance to the brightest star, Sirius, is 8.128 times 10 to the 16 meters, and the speed of light is 3 times 10 to the 8 meters per second, we can work out how far that distance is in light years. So we're going to use this formula. We know the velocity and we know the distance. We're working out time in seconds. Okay, so rearranging so that we're solving for the time. 8.128 times 10 to the 16 divided by 3 times 10 to the 8 will give us 2.71 times 10 to the 8 seconds. Now, if we convert this to years, like they've done here, using that same factor, so this was divided by 60 times 60 times 24 times 365, and it gave you 8.59 years. This is the time it would take light to reach Sirius from Earth, because light is travelling at the speed of light, so it's also the distance in light years. So the distance is 8.59 light years. So here is an example question. Canopus is the second biggest star in the night sky. It is 2.95 times 10 to the 18 meters from Earth. We want to calculate this distance in light years. So we know the distance it is from Earth in meters, and we also know the velocity at which light travels, which is 3.8 times 10 to the 8 meters per second. So we can rearrange this formula to solve for time in seconds. So 2.59 times 10 to the 18 divided by the speed of light, 3 times 10 to the 8. We've calculated this in seconds. We're then going to convert this into years, and this value is the number of years and also the number of light years away this object is. This is because light travels 1 light year every year. The last question here says that Vega is the 5th brightest star in the night sky. It is 2.391 times 10 to the 17 meters from Earth. You're calculating this distance in light years as well. So we know the speed of light is 3 times 10 to the 8 meters per second, and we're going to use this information. So you're putting down your formula, you're rearranging it to find time in seconds, you're then putting in your known values, 2.391 times 10 to the 17 divided by the speed of light, calculate your time in seconds, and then convert the seconds to years and light years using this factor here. That will give you 25.27 light years. That's the end of this tutorial. I know I've gone quite quickly, but I know people aren't going to want to watch 15 minutes or 30 minutes of me going through an Education Perfect lesson. I will print this out, give it to you in class, and you can use it to kind of like go through the calculations as well as you're watching the video. I hope it helps.